Salutations, mini mathematicians, and we're back. 3.2c, fill out your new notebook purpose, properties and proofs. Your purpose is to define properties to formally justify the steps of simplifying an expression or solving an equation. We're so close to solving equations. We need these for solving equations. So have out your packet you just got from your guest teacher, 3.2c lesson, and have out your properties that you already filled out earlier this week or last week with Video Bar, and that's going to be super helpful for you. The first 3/4 of this is just going over those properties again, and then we are going to apply these to proofs. Super mathy. Like if you tell your family and friends, like, I did proofs today in class, and they're like, oh my gosh, you're a true mini mathematician. So let's take a look. So properties and proofs. So in mathematics, there are governing rules or operations called properties. They're the rules for a set of numbers, and in today's lesson, we're going to formally define the properties of arithmetic, and you've used all along in math. There's nothing new in the properties discussed in this section. Everything you expect to work will work, and we're just giving vocab to what you've been doing so that when you construct an argument for an answer, I know some of you love arguing, you'll be able to use language with precision. By the end of this section, you should be able to define and explain the properties in words and symbols, and you should also be able to prove an expression simplifies using these properties. So our first property is a commutative property. So commute means to move or travel back and forth. So I live in Carlsbad, I work in Solana Beach, so I commute from Carlsbad to Solana Beach. I move back and forth for work. So some people say we commute to work. So we're going to look at all of these expressions, and I have little notes next to them, so thinking if they work or don't work. So 12 plus 4 and 4 plus 12. Yes, those are equivalent. They work. What about if we use subtraction? No, they're not equivalent. The order changed with subtraction. If we use subtraction again, it's not equivalent. The order changed with subtraction. Here, the order changed with multiplication, and it worked. Here, this is multiplication, the order changed, and it worked. Here with division, order changed and division did not work. So what pattern are we noticing? We're noticing if the numbers change or the numbers change order, if the expression was addition or multiplication, the value stays the same. If the operation was division or subtraction, the value changed. So this is the formal definition of commutative property of addition and the commutative property of multiplication. So please make sure to write all those down. And again, if you ever need to pause the video, please do so and then move on. Okay, the next property we're going to be looking at is the associative property. Associative property has S's and C's. That's what moves those parentheses. The word associate means partner or connect or group. So maybe you've heard of like a law group of like Bar and Associates, right? Most often we use the word to describe groups. If you went to Eastmont Middle School, you would be associated with Eastmont Middle School. Your associates are people you spend time with, your friends. So again, let's look at ones that work and ones that don't work. Here, we did 12 plus 4 first and then added 6. Here we did 4 plus 6 first and then added 12. It's equivalent when all the terms are added. Notice 12, 4, 6, 12, 4, 6. We didn't move any of the numbers. However, if we have subtraction, we do 12 minus 4 first and then subtract 3 versus 4 minus 3 first and then subtract that from 12. It's not going to be equivalent if our terms are subtracting. What if all the terms are adding? Again, notice 357.14, 357.4. We are not moving the numbers all, we're just moving those parentheses, the grouping of what we do first because of our order of operations. So if we do 3 plus 5 first and then add 7.4, that's the same as doing 5 plus 7.4 first and then adding the 3. It's equivalent when all terms are added. What about with subtracting? No, this does not work when it's subtracting. How about multiplying? If I do 5 times 4 first and then 1/2 versus 4 times 1/2 first and then times 5, when we multiply all the terms together, we can change the grouping and the product stays the same. What about with dividing? No, dividing, it doesn't work. How about with multiplying? Yep, equivalent when all the terms are multiplied. Dividing, no, not equivalent when all the terms are dividing. So something we notice is that when numbers are associated differently, the value stays the same if all the terms are being added or multiplied. The values are different if the terms are associated with the operations of division and subtraction. And again, remember, the order does not change. So notice I have ABC and ABC on both sides. This is the associative property multiplication. I'm going to group A and B together first, and I'm going to group B and C together first. The products are the same. With associative property of addition, again, ABC on one side, ABC on the other. I'm going to group A and B together first and then add C. Over here, I'm going to group B and C together first and then add A. We're going to have the same sum. Identity properties. Identity, I can put on a wig, I can put on different makeup, I could wear a mask, but my identity, it's still me, still Mrs. Barr. So the word identity has to do with sameness. The word identity has to do with sameness. We use this word when we recognize the sameness between things. Halloween costumes can't really change a person's true identity. Previously, we defined the associative and commutative properties for both addition and multiplication, and we needed the same thing with the identity property. So when you have the identity property, when you add something to a number, the value does not change. So identity property for addition, you're going to add to our number, but that number is not going to change. Is there a number you can think of that we add to any number and the number is not going to change? That's right, 0, 0 the hero. So some examples, 3 plus 0 is 3, negative 5 plus 0 is negative 5. So our official definition for identity property of addition, definition of identity property of addition is A plus 0 equals A. Adding 0 to any value does not change the value. So there's also an identity property for multiplication. When you're multiplying an expression by something, the value of that expression does not change. And remember, just one number is an expression, but we can also have an expression with operations and variables. So 3 times 1 is 3, negative 5 times 1 is negative 5. The official definition of identity property multiplication is A times 1 is equal to A. Multiplying 1 to any expression does not change the value of the expression. And we also have the multiplicative property of 0. Multiply any value by 0 gets you 0. 0 groups of anything is 0. So 3 times 0 is 0, negative 5 times 0 is 0. So here's the official definition of the multiplicative property of 0. And we've already gone over all of these and wrote them down, but it doesn't hurt to see it again. The next property is a property we've been working with a lot in this module. It's the distributive property. So there's the distributive property of multiplication over addition. And that's one of the reasons why we were always rewriting when we distributed, when we lassoed it up, the plus sign in between, because by the formal definition is that it's the multiplication over addition. So we have this 2 groups of 3 plus 2 groups of 4. So like all the previous properties we've used, we first show the property, rewrite 2 plus 3 plus 4, and then show it for A times the quantity of B plus C. So we can show it with numbers and with variables, and the distributed property is defined as A groups of B plus C equals A times B plus A times C, or A groups of B minus C is AB minus A times C. Inverse properties. We need these inverse properties to solve equations, so they're probably the newest ones for you, and they're super important because of where we're going. So the word inverse means opposite or reverse, so what would be the additive inverse of 3? How would you undo adding 3? Subtracting 3. Because 3 plus negative 3 is 0, the additive identity gets you the additive identity. We have been looking at additive inverses for a while because we started with the chips and tile models in module 2 with them. And then what would the additive inverse of negative 3 be? That's 3 because negative 3 plus 3 is 0, the additive identity. Remember, when you add your additive inverses together, you get the additive identity. The inverse property of addition formally states that A plus the opposite of A is equal to 0, or A plus negative A is equal to 0. So what do you think the multiplicative inverse of 3 is? Multiplicative inverse of 3 is 1/3, also called the reciprocal. That's right, reciprocal. Because 3 times 1/3 is equal to 1, and 1 is your multiplicative identity. And the multiplicative inverse of 1/3 is 3, because 1/3 times 3 is 1, the multiplicative identity. So when you multiply multiplicative inverses together, you get the multiplicative identity. And then our formal definition of the inverse property multiplication is A times 1 over A is equal to 1, A cannot equal 0 here. That's really important because we cannot divide by 0. Never give up, never surrender, and never divide by 0. You cannot do it. So if you multiply A by its reciprocal, the result is 1. Remember, A cannot equal 0. So we also have the substitution property. So substitution property is just when you're doing simplifying. So substitution property, you can think about it as simplifying, combining like terms. Combining like terms. Whenever you have just math happening, like 2 plus 3 gets you 5, that is the substitution property. I like to think about it more like simplifying and combining like terms, because a lot of times in proofs, you have a lot of substitution of things equaling what was above it, and it can be a little confusing. So substitution property, think about simplifying and combining like terms. Definition of subtraction, we've been working with this a lot. It's made our modeling so much better. A minus B is the same as A plus negative B. Subtracting a value is the same as adding its opposite. Hope you said that with me. So now we have our properties list, and you have already filled that out, and I hope you have it handy because it's going to be super helpful as we finish these last 2 pages of our lesson. So it says, name the property / definition shown and use the complete name. So you're going to want to have your list out so you can look at all those words. And let's take a look at what changes. It's really important to highlight what changes from one side to the other side. So notice I have 253 and 253, but what changed is the parentheses around the numbers. So 253, 253, the numbers did not move, but the parentheses did. So which property is that? That's right. Associative property has S's and C's. That's what moves those parentheses. So this is the associative property of, because they're all multiplying, multiplication. And it says to use the complete name, and we follow our directions around here. So let's take a look what our next one is. It says 9 plus 0 is 9. So I'm adding 0 to a number and not changing it. Oh, I know something that's not changing. That's an identity property. And it's adding, so it's the identity property of addition. Identity property of addition. No shortcuts here. Okay, let's look at the next one. We have 7 times 23 is equal to 23 times 7. So notice the order changed. The order changed, and we're multiplying. What is it when numbers move and you're multiplying? Oh, that's right, the commutative property of multiplication. Commutative property of multiplication. And flashcards could be a great idea for these properties so you know and understand them super well for the exam. 794, 479. I see these parentheses, so I automatically want to think associative property multiplication, but the first thing I checked was if the order moved. So I see 794, 479. So I see that the order moved. So what happened here? I have 7 and 9 and this 4, and this 4 and the 7 and the 9. So the 4 switched place with the whole group of 7 plus 9. So really the numbers are moving. Oh, but it's just, instead of just one number, it's this whole group of numbers. Did you know they could do that? Oh, so this is the commutative property of what operation's happening? That's right, addition. So sneaky. Commutative property of addition. Beautiful. Let's look at the next one. Okay, we have 6AB, 6AB. Okay, so the order did not change. Let's see if something did change. We have 6A and then being multiplied by B, and then we have AB being multiplied by 6. So the only thing that moved was those parentheses. Associative property has S's and C's. That's what moves those parentheses. Beautiful. And then what operation's happening? Multiplication. So we know this is the associative property of multiplication. Sorry, we don't have copy and paste with our eyeballs. Okay, last one I'm going to do with you, and then I'm going to let you go from 7 through 19. Number 6, 12A5, A12-5. Okay, so I'm noticing that the numbers moved around. The numbers moved around. So we have 12A and then 5, and then A12. And so what numbers moved? Oh, the A and the 12. The A and the 12 are the ones that moved, and they're being multiplied together. And when numbers move, it's like commuting, like moving to work, commuting to work. The numbers are moving, it's multiplying. The property is commutative property of multiplication. Commutative property of multiplication. Beautiful. You go and finish 7 through 19, pause the video, finish 7 through 19, and we're going to go over them in just a jiff. Did you pause the video? Okay, let's go over it. Number 7, substitution property. Remember, substitution property is just simplifying. It's just simplifying, combining like terms. Combining like terms. 5 plus 3 turned into 8. That's the substitution property. Next one, identity property multiplication. 1 times something is that something. We have the additive inverse property. A number plus its opposite is 0. And again, totally fine if you're using that property list to fill this out. But you're going to want to make flashcards. Ooh, distributive property. 3 times the quantity of x plus 5 gets you 3x plus 3 times 5. Commutative property of multiplication. 17 times m is the same as m times 17. Commutative property of addition. 6 plus a is the same as a plus 6. And notice I am marking up those expressions, so I am really showing I know what's moving before I'm thinking about the property. Distributive property. Put a star next to 13. Maybe this is one you got stuck on. This is kind of the backwards distributive property, and we're going to be looking at that in the next lesson. This is saying y groups of x plus 5, xy plus 5x. So if you thought about going backwards, I could have shown also x plus y plus 5y is equal to y groups of x plus 5. So this is a distributive property. Next one, identity property of addition, adding 0 to anything. Is that anything? Associative property multiplication. Associative property has S's and C's. That's what moves those parentheses. And again, 4BC, 4BC, the numbers did not move. The numbers did not move. 16, definition of subtraction. Subtracting a number is the same as adding its opposite. 17, commutative property of addition. We switched the order and we're adding. Next one, distributive property. So this is the one I was hinting at when we looked at 13. 2y plus 2x. A common factor is 2. So we can pull that factor out, kind of like undistribute it. And it's 2 groups of y plus x. So this is going to be super important for our next lesson. Multiplicative inverse property. A number times its reciprocal is equal to 1, the multiplicative identity. And now we're ready for our first proof. Dun, 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 dun. Okay, so we are going to be using properties and complete the following algebraic proof stating the property that is used to advance to the next step. So let's take a look. This line is how did we go from here to here? Just completely ignore the rest of it. How did we go from here to here? What changed? Think about just like above. What changed from here to here? We have AB plus negative B and AB plus negative B. And it looks like we added in these grouping. Oh, but there was grouping over here. So before we are adding A plus B first and then adding negative B, and now we're adding B plus negative B first. Oh, so we changed the grouping and we're adding associative property of addition. Associative property of addition. Now we're thinking about just going from here to here. And if it is helpful for you to rewrite A plus B plus negative B and thinking about it like number 1 through 19 above, please do that. Make it easier for you. So what happened just from this step to this step? What happened from this step to this step? What tells us that B plus negative B is equal to 0? So some of you might be thinking substitution, but there is a rule that tells you a number plus its opposite is 0. Do you remember what that is? That's right, it's just like algebra tiles. It's the additive inverse property. Additive inverse property. It's like a 0 pair. Okay, so now, again, it might be easier for you to think A plus 0 gets you A. Just ignore everything else that already happened and just look at this step. What rule, what property, what governing law of the numbers lets us know that A plus 0 is going to be A? Adding 0 does not change its value. Ooh, that's an identity, and we're adding is the identity property of addition. Identity property of addition. Great job, mini mathematicians. We're almost there. Let's look at the next page. I'm going to do number 22 with you, and then you're going to do 21 and 23 on your own, and we'll come back and check it together. Okay, so again, we're going to ignore everything else on this problem and just look from here to here. And we're going to investigate, and we're going to think, what happened? What changed? Maybe you have to get closer to your paper to see. Oh, I see it. I see what happened. This multiplied together to make this. A number times its reciprocal made 1. Multiplicative inverse property. Jinx. Multiplicative inverse property. And maybe you said it was the inverse property multiplication. Tomatoes, tomatoes. Okay, let's take a look at the next one. And again, if it's helpful for you to rewrite, this is 4 groups, 1 minus 1 plus 7 is equal to this, and ignore everything else. Ignore everything else. Do that. Make it easier for you. Proofs can get tricky. So what happened here? What changed into what? Ooh, I see that 1 minus 1 turned into 1 plus negative 1. Oh, so what tells me that I can turn subtracting 1 into adding negative 1? Subtracting a number is the same as adding its opposite. Definition of subtraction. Ah, perfect. Definition of subtraction. There's going to be some think time. There's going to be some think time. Okay, now let's look at the next one. Again, rewrite it to make it easier. We're saying 4 groups of 1 plus negative 1 plus 7 turned into this. Ignore what happened previously. What changed? I see it. 1 plus negative 1 turned into 0. 1 plus negative 1 is equal to 0. A number and its opposite is equal to 0. Oh! Do you know what it is? Do you know what it is? A number and its opposite gets you 0? On 3. 1, 2, 3. Additive inverse property. Ah! Additive inverse property. And could you have also called it the, I guess you have to add it, property, additive inverse property, the additive inverse. Okay, let's look at our next step. Oh, we're almost at our final step. And again, if it's helpful for you to rewrite it, please do. 4 groups of 0 plus 7 gets you this. What changed? What happened? Ignore everything else. Ignore everything else. What do we have? What tells you 4 times 0 turns into 0? What governing rule tells you a number times 0 is 0? Multiplicative property of 0. 0 multiplication property. Multiplicative property of 0. Nice job. Okay, we have our last step. Our last step tells us 0 plus 7 is equal to 0. Sorry, erase that. 0 plus 7 is equal to 7. What tells us that 0 plus a number is still that number? It didn't change. It's an identity. It's adding. Identity, property of addition. Identity, property of addition. Dun, da, da, dun. Our second proof ever. Okay, you're going to finish 21 and 23. Pause the video, and then I will go over it with you. Let's do it. Okay, 21, we have commutative property of addition. The numbers moved. Associative property of addition. We regrouped the C's together first. Then we have the additive inverse property. C plus negative C turned into 0. Then we have the identity property of addition saying D plus 0 is equal to D. And on 23, we have the distributive property first. Distributive property, 3 groups of 2 plus 3 groups of C turns into 3 times 2 plus 3 times C. Then we have the substitution property, which is combining our like terms. 3 times 2 gets you 6, 3 times C gets you 3C. Then we have the commutative property of addition. We just said 6 plus 3C is the same as 3C plus 6 because we wanted those like terms next to each other. Then we have the associative property of addition. We're adding in those groups to say we're going to do this first. Then we're going to factor out that C term. So it's kind of like backwards distribution property, but it's just distribution property. And then we have the substitution property saying 4 plus 3 is equal to 7. Excellent job, mini mathematicians. You are fabulous. Video bar out.